Hi scholars, today we're going to talk about decimal representation. So for example, let's just start out with the number 423. Now we know that this 423, this 4 is referring to the fact that we have 4 of these things that are hundreds. The 2 is referring to the fact that we have 2 of these things that are tens. And the 3 is referring to the fact that we have 3 of these ones, or 3 units, right? And so the question we want to ask ourselves is, what would happen if I did 423.68, for example? What does that 6 refer to, right? This 6 is 6 of what, right? That's sort of our question. 6 of what? And this 8, what would that refer to? And we can sort of piece this together, in fact, just by following a pattern. Often in math, it's really helpful to look at, just find patterns and just follow them. So we have that each of these digits are sort of representing different place values, right? The 4 and the 2 and the 3. We can move from one of these place values to the other by dividing by 10, right? 100 divided by 10 gives me 10. 10 divided by 10 gives me 1. So let's continue that pattern. 1 divided by 10. What does that give me? Well, it gives me 1/10. So this 6 is actually referring to tenths, right? Here, I'll just write it over here. The 6 is referring to tenths, which is how many units of 1/10 do we have? Now we can keep this pattern going, of course, dividing by 10, and a tenth divided by 10 is 100th. And so the 8 is actually referring to, right, hundredths, okay? And so we can see sort of this pattern emerging where the digits in a decimal representation of a number each refer to some power of 10. Okay, so 100, 10, 1, a tenth, 100th. We can imagine it continuing on in this direction, getting larger, 1,000, 10,000, 100,000, a million, and getting smaller, 1,000th, 1/10,000th, 1,000,000th, and so forth and so on. So let's take a look at a couple examples, and we can sort of see the benefits of this way of representing numbers, right? And so one benefit is that we can very easily, using our Base-10 system, that's what we operate in, we can very easily multiply and divide by powers of 10. So, for example, without doing any calculations, perform the following operations on this number. This number is 238.7. And so we're going to divide it by 10. I don't need a calculator for this, in fact, right? If I have the number 238.7, I can divide it by 10, means make it 10 times smaller. Because of what these numbers represent, each one is a power of 10, it's as simple as moving a decimal point over, okay? So now I have my new decimal point is right here. I made the number smaller. Instead of 238, it's 23.87, right? And that's our answer, 23.87. That is this number, 238.7 divided by 10. Let's multiply it by 100. Well, in the same way that we can make numbers smaller by moving the decimal places over to the left, we can make them larger by moving it over to the right, of course, right? And in this case, we want to move it over not just, we don't want to just multiply it by 10. That would multiply it by 10, moving the decimal point here. We want to multiply it by 100, which is 10 times 10 again. So we want to move the decimal point over twice. And here's our new decimal points, and we want to ask ourselves, well, what goes in here? And the answer is 0, and it's not because of anything really magical that there's a 0 here. It comes from the fact that 238.7 is the same, it's identical to if I had said 238.70 or 0.700, right? There's an infinite string of zeros after every number that goes on forever, and in fact before as well, right? I could say, how many thousands do I have? I have 0 thousands here, right? We just don't write the zeros because they're not helpful to us. However, in this case, when we move the decimal place over twice, we need a filler here. So this is going to be our final answer. When I multiply it by 100, the answer is 23,870. And if I want to multiply this number by 1/10, well, multiplying a number by 1/10 is the same as dividing it by 10. It's the same. They're identical, right? One thing implies the other. And we can reason about this by saying, well, if I multiply this thing by Here we use a different color. If I multiply this number by 1/10, it's the same as taking this number, 238.7, and dividing it by that 10, right? We can multiply across or however you want to reason about it. And this problem we've already done. We already know the answer, right? So that's the answer, right? This is the same answer, 23.87. Okay, that's great. Let's do one more. Theo thinks that 0.026 is equal to 2/10 plus 6/100. Is he correct? Well, we can reason again. Reasoning about our place value, we know that if this is our decimal point, if this is the decimal point right here, right, we know that the immediately to the right of it is tenths. So this is the tenths, right? And how many tenths does he have in this number? There are 0 tenths. The 2 is going to represent how many hundredths? So he has 2 100ths. Okay, 2 over 100, and the 6 is going to represent, we just keep moving on, keep getting smaller, 6 1,000ths. Oops. 6 1,000ths, right? So we have 0 tenths, 200ths, 6 1,000ths. So is he correct? He is not correct at all, right? We don't have 2 tenths in this number. We have 0 tenths. So he is incorrect. Is he correct? No. Wrong, right? This number that Theo was writing, 2/10 plus 6 100ths, that's actually just 0.26, right? Because then we would have our place values match up, tenths and hundredths, okay? Second question says 0.026, same number, is 26 of what, right? It's 26 of something, but what is it? Is it 26 hundredths? Is it 26 thousands, right? What is it? 26 of what? That's really what this question is asking. And now I know that you could look at this sort of procedurally and say, well, okay, let me make this thing over 1, and let me cross multiply, right, and solve for x. You could do that, but we can just reason through it, okay? This thing, we've already said, was 0 tenths, 2 hundredths, and 6 thousandths, okay? So we already said that this was 0 tenths, 2 hundredths, and 6 thousandths, okay? Well, 2 hundredths is how many thousandths? 20, okay? 0 tenths is, well, 0 hundredths. It's also 0 thousandths, okay? And so what we can do is we know that this number is comprised by the sum of these 3 numbers, and we see immediately the answer is 26 over 1,000. So the answer is solve for x. The answer is x equals 1,000 in this case, because that's how many thousandths. And we say, oh yeah, this looks a little complicated. Can we check it with a calculator? We certainly can, right? 26 divided by 1,000. There it is, 0.026, right here, 0.026. Beautiful. Okay, so before we go, I'd like to call your attention to one observation. It so happens that sometimes when you are looking at decimal representations of some numbers, so for example, if I go 2 divided by 5, 2/5, right? This is basically saying that 2/5 equals 0.4, and 0.4, and then the decimal representation just stops, right? So this just stops, and it sort of terminates. We can call this a terminating decimal, okay? Because it stops, it doesn't go on. And sometimes, however, if I want to do, for example, 2 divided by 3, which doesn't look too much different from 2/5, you press enter, and oh my goodness, it looks like this thing goes on forever. So sometimes you get representations, decimals that go on forever. 666 dot 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 goes on forever. We actually write this as 0.6 with a bar in it, and so this one is a non-terminating decimal. And we might want to ask ourselves, based on the conversation we just had, where we know that each one of these place values represents some factor of 10, right? A tenth, right? That's a tenth. That's a hundredth. That's a thousandth, right? We might want to ask ourselves, what would make one fraction stop when you write it as a decimal form, and another fraction go on forever. What characteristics, right? This 4, for example, we can do 0.04. So let's just go real quick, and then we'll let you go. So this 2/5, we know we just said it equals 0.04, and that's really 4/10, right? And yeah, clearly 2/5 equals to 4/10. You can double check it by doing cross multiplying, right? Just to make sure. Or you can also reason proportionally, right? So clearly that is the case. And so the fact that there's a 10, right, in the denominator here, that allows this decimal to stop. Okay? So that's just like a hint for you. All right? Have a great week.